Here we have a limit problem. They're asking us specifically to find the limit as x approaches infinity of this huge equation here. Whenever someone asks us about the limit as x approaches infinity or negative infinity, that's also them asking us about the horizontal asymptote, the long-term behavior of the graph. So both of these things, all these things mean the same thing. So horizontal asymptote, long-term behavior, limit as x approaches infinity. In this example, rather than doing it the quick way, which is just using leading behavior and seeing if it's top heavy, bottom heavy, or balanced, we're taking this on as if we have to show all of the work to where we get to this final conclusion. And so to do that, usually what you need to do is divide by the highest power of x. So that is the dominant term in the entire equation, and so we're going to divide everything by that highest power of x once you find it. So looking at our situation here, we've got an x to the third on top, an x squared, an x to the fourth, and an x to the third. So x to the fourth is our dominant term. So to show your work, usually on an in-class test, usually not as much on an AP Calc test, you divide everything by that highest power of x. So 12x to the third divided by x to the fourth plus 128x squared over x to the fourth. And then all of that's over x to the fourth divided by x to the fourth plus x to the third divided by x to the fourth. And now what you're going to do is you're going to come through and you're going to simplify this down really quickly. And what you'll use to simplify it down is this definition that they like to give you when you're working on this. They say, okay, the one thing we will tell you that you can use is that the limit as x approaches infinity of 1 over x, that equals 0. And this basically holds true no matter what the power on that x on the bottom is. As long as that power is some big power, and as long as there's just a single number on top, you can conclude that that's going to equal 0. So looking at what we have up here, as we start coming through, we can cancel x to the third is going to simplify down to just giving us 12 over x. And so what we get out of that is that is all headed to 0. It's following this definition right here. So this is going to equal 0 plus, and then x squared cancels two of these on the bottom here. Again, you're still in one of these scenarios where you've got the bottom has the x in it, so that gets us to 0. And then on the bottom now, x to the fourth divided by x to the fourth, those cancel each other out. And what you're looking at in that situation is a 1. X to the fourth divided by x to the fourth gives us 1. And then on the next piece, that's going to cancel out with all of those there. So again, we're looking at 1 over x, which is telling us, again, using our definition, that this thing is headed to 0. We get to simplify to that point, and then as we simplify this equation more, on top you get 0, on the bottom you get 1. So 0 divided by 1 is going to equal 0. And so that tells us right there that our horizontal asymptote, or the solution to this problem, is y equals 0. The limit as x approaches infinity of this equation is y equals 0. Limits are always a y equals as the answer. That also tells us that the long-term behavior of this graph, or the horizontal asymptote as we head to infinity, is 0. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.